The first item is that this session will be recorded and will be posted at a later date. So one of the call outs for that is if you don't want to be recorded, please just make sure that you turn off your video. So that means that only your name will be shown for the session. The second one is if you could please just make sure that your microphone is muted. We'll be running a Q&A at the end of today's webinar, and what that means is throughout the session, if you have any specific questions, it'd be fantastic if you could just type them in the chat. And what that means is that we can then select a couple of those questions and answer them at the end of the session. The other thing is that we're going to be running some polls throughout the session to be able to understand your familiarity with Databricks, as well as your level of cloud adoption and how well you thought we went today. So it'd be really appreciated throughout the session if you do see a poll pop up on your screen that you just submit an answer to that. So getting into the agenda for today, we're going to be going through a bit of a quick introduction to who I am and who my company is. We then want to start with a why. Obviously, we're living and operating in a very interesting climate at the moment, and that climate has given us some reasons to start thinking about innovation, or rather forcing us to innovate. From that, we're going to go through what is machine learning, how can we create value through machine learning, what are some of the use cases, and presenting a case study on how we helped a customer deliver value through machine learning. Before Jan's going to be going through a bit of a presentation and a demonstration on accelerating machine learning with Databricks on Amazon Web Services, and then we'll open up to everyone for Q&A. So a bit about myself. My name's Cal Temple. I'm the co-founder and co-CEO of Intellify. I've been working in data analytics and machine learning consulting for over 5 years. I'm an honorary affiliate at the University of Sydney Business School, and I've supervised over 50 different machine learning projects. My background is I've got a Master's of Economics in Econometrics, where I specifically did a piece of work around quantifying the accuracy and interpretability trade-off in machine learning, which is around pulling apart black box models to understand why they're making decisions. In terms of who is Intellify, we're a data analytics and machine learning consultancy, been around for 2.5 years with 25 people, delivered projects in 5 different cities across Australia, as well as done some work in New Zealand, Switzerland, and the US. How we help customers in 3 different ways: through strategic advisory, where we help customers to understand the value of machine learning. And the second is if you've got a project that you want to come along and execute, we have the ability to come along and develop and implement that machine learning project for you. And lastly, around enablement, we know that there's a lot of teams out there who have data scientists and data engineers, and we help them to essentially deliver the best possible outcome by transferring knowledge to them, by upskilling and also teaching them best practice. 2 specific call outs is that we were the Amazon Web Services Partner of the Year in 2019 for data analytics and machine learning. We're also 1 of 2 machine learning competency partners in Australia and New Zealand. We've been able to deliver a whole bunch of outcomes to customers. Specifically, we've delivered over 100 different projects, but we've been able to do everything from predictive maintenance through to recommendation engines. So it looks like most people have been able to join the session. So I want to move into the main purpose, which is around why businesses are being forced to innovate. And the short answer is that we are faced with a new reality. A reality where Australian consumer sentiment has dropped by its largest amount in 47 years, where the price of US oil has turned negative for the first time, and where consumption behaviour is becoming increasingly conservative, and where digital experiences are now mandatory rather than nice to have. What this means is that for businesses to be able to survive this crisis, they need to drastically rethink their cost base, how they drive stickiness with customers, their operating model, but also this means that all these things point towards a need for an accelerated digital transformation. So what we would say is that there's 3 actions that need to be taken by energy and utilities to be able to cope in the current climate. The first action that needs to be taken is that energy and utilities need to understand how they can change or influence their cost structure. With the price of oil and LNG dropping to their current levels, energy producers need to rethink and examine every aspect of exploration, development, production, transportation, and refining. And obviously, one of the ways to do this is to use data analytics and machine learning to optimize each of these different activities. To give you an example, we've done some work with a large LNG producer in Australia to build machine learning models that increased well availability by detecting when a well was operating in a harmful state, potentially leading to a costly breakdown. Another example of how we've been able to work with a utilities business that has been able to impact their cost structure is how we worked with a leading geosurveillance business to automate 85% of their radar classification process, which was around speeding up the time to value for that specific business. The second action that needs to be taken by energy and utilities that have customer-facing businesses is to use data analytics and machine learning to attract and drive stickiness in and across their customer base. The main levers that these businesses can pull is to drastically improve their digital experience by demonstrating at each touch point that they know and understand their customer and that they can create additional value for their customer on top of the energy and utility products that these companies produce. For example, we've been able to work with a very large energy retailer across 2 different programs of work, which were designed to improve their customer experience. The first initiative was designed to give customers personalized and relevant offers by using machine learning models to predict the types of offers and products that were most relevant to them. What this meant is that when they came to that business's website, or for example, if they're interacting with them via the email channels, they were able to understand how that business could obviously help them, but also what types of offers that business would be able to provide to them. The second initiative was designed to improve their visibility on consumer and operational issues by leveraging their customer call center data. What we ended up doing was essentially building a solution that transcribed their customer call data and then analyzed each of these transcribed calls to be able to understand reoccurring themes and topics in each of these calls. And what this meant was that in near real time, they would be able to flag operational or customer service issues that were being reported by customers rather than having to wait until the end of the month to be able to see what type of general patterns and trend they were experiencing in their call centers. The last action that needs to be taken is about understanding how business models need to change, to minimize the risks presented by coronavirus. This means that energy and utilities businesses need to look at their customer base, their preferences, and how they've changed based on this new state of the world. For example, we've seen that customers have become massively more price sensitive, which obviously means for utilities businesses that they're going to have increasingly higher churn rates, which means that they need to be able to build new products and offers that need to be able to fill this new customer demand. So for example, if these energy and utilities businesses were previously offering premium products to their customers, they might need to now start thinking about how they can actually start tailoring their products to be able to meet their needs, the new needs of these customers. Further, with management having a duty of care to their employees and customers, energy and utilities need to look at how they can minimize their stakeholders' exposure to risky environments or situations. And what this means is that obviously customers don't want to be able to leave their houses to be able to interact with these businesses. And what this means is that you need to be able to have world-class digital experiences for your customers to be able to make sure that they can effectively transact with your business, given the current climate. But also the second point is around worker safety. And this means that if you're a business who is operating, offshore oil drilling centers, or for example, wells in the middle of Australia, it could be the fact that you need to start investing in remote monitoring capabilities to be able to minimize the amount of time that your employees are spending in at-risk environments. So let's take a step back from why businesses need to innovate. And the reason I want to do this is I want to quickly touch on the different types of analytics and how machine learning and artificial intelligence are different from traditional analytics. The reason being is that most businesses are quite familiar with business intelligence reporting, but few businesses are familiar with machine learning and artificial intelligence. So I first want to start with what is descriptive analytics. So descriptive analytics is the process of using your historical data to understand what has happened through some form of aggregate statistics, such as averages, so that people can then interpret this information to be able to combine it with their own knowledge to be able to make decisions about what will happen. So for example, if we take the perspective of an energy retailer, it could be the fact that they look over the last 6 weeks worth of energy consumption data. And in that energy consumption data, they then come along and apply their own subject matter expertise to be able to then give a subjective forecast about what's going to be happening in the next 2 weeks. And what I would say is that this type of descriptive analytics, this business intelligence and analytics, is ideal where you have situations where there's limited data, either in terms of the length of the data, so you might only have 3 months worth of data or 6 months worth of data, or you have very little data that actually describes the process that you're trying to make predictions about. So for example, if you're trying to make predictions about energy demand, and you don't have the ability to pull in weather data or whatever it is, it could be the fact that this is a really good use case for descriptive analytics because you don't have the type of data required for predictive and prescriptive analytics. So predictive and prescriptive analytics, on the other hand, is about using historical data and advanced mathematical algorithms to detect and learn sophisticated patterns in the data that a person wouldn't normally be able to pick up on. And what that means is that there's more accurate decisions that can be made by being able to use these sophisticated algorithms to be able to understand these fine patterns that are happening in the data. And what you'll find is that this type of analytics works well when you obviously have large amounts of historical data, but also data that describes the process that you're trying to predict. So, for example, we would find is that we would find that because a lot of businesses have quite mature business intelligence and analytics practices across their organization, most organizations are actually in a very good position to start adopting predictive and prescriptive solutions. And what this means is that even though they have the foundations to be able to do this, very few organizations have been able to step into these more advanced methods. So one question you might ask me is, what is the difference between predictive and prescriptive analytics? And the biggest differentiator is that predictive analytics is about predicting what will happen, while prescriptive analytics is about giving you recommendations on what is the best course of action. So rather than just coming along and predicting the energy demand for the next 2 weeks, a prescriptive analytics solution would come along and say, this is the exact amount of energy that you would need to purchase to be able to optimize the load on the grid. So if we start speaking about, if we start moving on from the different types of analytics to how can we create value through machine learning, we can see that there's 6 primary value drivers as to why businesses want to be able to leverage machine learning. So obviously the first one is around using machine learning to reduce costs and increase efficiencies. And given the current climate, we believe that this is obviously the biggest focus area for most energy and utilities businesses. Examples of how you can achieve this are through solutions like predictive maintenance, the optimization of service or delivery schedules, or automation use cases. As mentioned previously, we've been able to work with a large LNG business to be able to implement a predictive maintenance solution on their wells, and we've been able to also work with a large geosurveillance business to automate the classification of their LiDAR radar images. However, what we've also seen is that for some customers who run LPG businesses and waste management businesses, some of the things that they can use machine learning to do is to forecast the amount of consumption that their customers are going to be having over the next 2 weeks, 4 weeks, 6 weeks, and 8 weeks, to be able to then optimize their delivery schedules, obviously saving money then on the transport and logistic costs across the organization, bringing down the total unit cost of them being able to provide services to their customers. The second area is around making your business faster and more scalable by using machine learning to allow your output to scale to your compute power rather than to your human resources. So what we end up finding for this specific value driver was that one of our customers who was trying to review credit limits only had the human capacity or bandwidth in the organization to review 15% of credit limit changes. And what this meant is obviously that business was bearing additional risks from obviously credit risks, becoming worse than expected. But at the same time, they had a whole bunch of B2B customers who came to them and said, what we need to have our credit limit increase. And it was a very painful process. So what we ended up doing for them was actually working on how can we use machine learning to forecast the accurate credit limits that they need, which then ended up minimizing the downside risk, the credit risk that business was willing to take, but also making sure that customer got a good experience by not running into credit limit frictions. And what that meant is that rather than just reviewing 15% of their credit limits, we could then now help them actually review every single credit limit increase or decrease that was suggested by one of our customers. The third area is around increasing worker safety by combining IoT solutions with machine learning to provide a sense of sight and hearing in work sites that contain high-risk environments. For example, what we've found is that workers in energy may need to drive long distances into the middle of nowhere under extreme heat to access their different work sites. And once they're on this work site, their primary job is to ensure that obviously everything is working correctly. This might be around, listening to be able to hear that their pumps are working accurately, or it may be about checking water reserves on site. And what you can do here is actually you can install an IoT device with the ability to process, take in and process audio signals to be able to continuously monitor those pumps in these remote work sites to be able to detect whether something is actually going wrong or there's some form of anomalous behavior. And what this means from a worker safety point of view is now that worker doesn't have to drive as far in adverse conditions and put themselves in risk to be able to ensure that their business is being operated in the most effective manner. The fourth area is around improving the accuracy of decisions of the accuracy of decisions across your business. And what we've found is that we've built about 100 different machine learning solutions for customers. And typically at a minimum, if you're able to compare existing legacy solutions to the machine learning solutions that we've personally been able to build, we've been able to find at a minimum some form of double-digit improvement in the accuracy of these solutions. And what that means is that if you start speaking about the amounts of decisions that are made inside your business, and if you could improve the quality of those decisions by 10%, 15%, 20%, 30% or more, obviously businesses can then better interact with their customers by providing them with more accurate recommendations. They can better manage their risks, but they can obviously better balance supply and demand across their organization. The fifth area is around minimizing key personnel risk. What we find is that a lot of energy and utilities businesses have engineers who have been working in that business for 10, 15 or 20 years, which is great. But the challenge there is that they've amassed a huge amount of tribal knowledge, which is obviously invaluable. The challenge is that obviously if that employee moves to a competitor, they decide to retire, or for example, they can't work for health reasons, that business now faces a huge loss of critical information. And what that means is if that knowledge can't be passed on to other people, that business is actually being hamstrung to some degree. So what we've actually found is that for some of these organizations who have really experienced engineers, you can actually use machine learning to learn, to understand and codify some of these critical decisions that are being made by engineers, which means that if there's new staff that are being onboarded, they can start leveraging these machine learning solutions, which means that essentially their capabilities are being augmented to being best-in-class engineers who have been making the right quality decisions across their business for 10, 15, 20 years. And lastly, the biggest challenges, the biggest value that can be created for energy and utilities is the fact that they're a producer of homogeneous goods. And what this means is that to be able to differentiate themselves from their competitors, they essentially really struggle to do it through their product offerings. And what this means is that for them to be able to differentiate from their others, from their competitors, they need to be able to differentiate through their cost structure, or they need to be able to differentiate through their customer experience, or creating value-added data and digital products which they can offer to their customers. And obviously this is where you can use machine learning to improve the operational efficiency of your business, meaning that you have a cost advantage which your other competitors can't compete with. So if we start moving on from how are businesses using machine learning to create value to where are businesses applying machine learning to create value, there's one really strong core theme that stands out. And this is that there's two primary drivers of why businesses exist. The first is obviously to acquire customers and market share. And the second one is to obviously minimize cost, which means that if you take the two of those, it's around maximizing profits. And not surprisingly here, if you look at the total value created by analytics or artificial intelligence solutions, a report by McKinsey ended up finding that marketing and sales was the biggest value driver of these solutions, which is obviously around if you have a retail business, or if you have a retail business, one of the strongest areas that you can apply machine learning and artificial intelligence is to actually make customer acquisition more efficient and also improve how you engage and work with customers. But the second thing is around making sure that you've got a really efficient supply chain from generation or production all the way through to transmission and distribution. What I would say is that this is actually in line with the experience that we've been seeing in the Australian market. This study was obviously a global, worldwide study. What we've seen in working across many different areas, across many different business functions, that this, when you start speaking about where we've seen organizations want to apply machine learning, this is the exact same finding that we've been seeing. So moving on from you know, where a business has been applying machine learning inside the organization to what are some of the specific use cases that energy and utilities businesses can use machine learning for, we see that there's 6 broad themes. The first theme is that they use machine learning for demand forecasting. And this could be around using machine learning to estimate the amount of generation from wind or solar farms, or it could be to forecast the amount of consumption from residential, business, or industrial customers in terms of how much energy or utilities they're going to be consuming. But ultimately, these types of demand forecasting activities around demand and supply modeling are around how can we actually use machine learning to better capacity plan and obviously to optimize that capacity. The second broad theme is around using machine learning to enable predictive maintenance. And predictive maintenance is a use case that obviously has very broad applications across both energy and utilities, and is essentially around how can we maximize asset uptime and availability. If we start speaking about where are some of the applications that we've seen in predictive maintenance be used, it can obviously be used to predict failures in wind turbines, or it can be looking at failures in the belts that load coal into power generation stations. Or for example, in transmission, it can be used to predict vegetation encroachment. Or for example, in energy or oil production, it can actually look at the different states that the machine is in to see whether the machine is in a harmful state or about to fail. The third broad theme is around maximizing yields or yield optimization, which is around maximizing the amount of output while minimizing the amount of inputs that will go into that process. And a really good example of this is around when you start speaking about refining oil or liquefaction of natural gas. There's a whole bunch of factors that go into producing these goods. And obviously there's a whole bunch of different parameters that can be set in terms of producing that same output. And typically there's an extremely high energy cost to be able to do these two things. And what that means is that you can use machine learning to be able to understand what is the optimal set of parameters for those inputs to be able to maximize the quality of the output and also the output of liquid natural gas, as well as refining of oil. And this means that obviously there can be very large energy savings realized by these types of businesses. The fourth is around remote monitoring, and this is where you can use Internet of Things solutions or drones to minimize the amount of time that people spend in risky environments. For example, it could be around using drones to inspect offshore oil rigs for corrosion, or it could be around using IoT devices inside facilities to augment existing legacy solutions to minimize the time needed for people to perform manual inspections of instruments. So this is the fact that if you're talking about facility management for LNG or for any other form of processing activity, there might be a whole bunch of legacy SCADA systems or instrumentation systems. And to be able to digitize these systems, you can actually use computer vision solutions or IoT solutions to actually read these outputs. And this is critical where these instruments might be 10 meters off the ground in a risky environment. And this means that we're minimizing the amount of time that workers are being put in these high-risk situations. The fifth theme is around using machine learning to maximize the value or payoff of the commodities through trading. We know for a fact, with working with quite a few different energy businesses, that a lot of them are making money from their trading businesses rather than their retail and consumer businesses. And what this means is that these energy and utilities trading houses need to be able to start thinking about how can they leverage state-of-the-art systems to be able to maximize their returns in addition to what they've typically been doing from a trading perspective. And the last one is around, most energy and utilities businesses have some form of retail-facing business as well. And this means that they have the ability to do all the good retail use cases, such as using machine learning to market and sell more effectively, or to offer more personalized and engaging experiences to customers. And this is not necessarily saying that these are the only use cases that we've seen in the market. But if you took a step back and said, what are the core themes that we're talking about? To energy and utilities businesses about. These are the six broad themes. So before I hand it over to Jan, I just want to quickly cover one of our case studies where we ended up working with Alinta Energy to improve their energy consumption forecasts for their commercial customers by building them a state-of-the-art time series machine learning solution. So we ended up working with both their business and technical stakeholders over a course of only 6 weeks to understand the nuances and complexities of their use case, and then prototype a solution, which was then put into production to be able to run against their existing forecasting solution to be able to establish a comparison. What we end up finding after having our solution running against their production system for a matter of weeks was that we were able to achieve a triple-digit % increase in the quality of their demand forecasts, which you can speak about, which from a capacity planning and from a capacity optimization point of view. Obviously, if you're able to get a really good outcome from an individual consumption forecasting point of view, this means that they can now better plan and better manage their capacity. So I'm going to now stop sharing my screen and hand it over to Jan. As mentioned, we're going to be doing question and answer at the end of today's session. So if you want to type any questions now into the chat about my specific part of the session, we'll cover it later on in the question and answer session at the end of today. So Jan, over to you.
Cool. Thank you, Kale. Let me just find a way to share my screen in a second. Thanks for the introduction. As Kale mentioned, my name is Jan Moiseev, and I'm a solutions architect here at Databricks. Most of my background is in machine learning and data science. So I've spent my career helping teams and organizations to go from zero to machine learning in production in a very short amount of time. So ask me any questions about ML. But before we kind of go deep into the demo, I just wanted to talk a little bit about Databricks and who we are. When I mention Databricks, people typically ask me, well, aren't you people who have created Apache Spark and are now offering some consulting and training services around it, which has been the case. And in fact, our founders are also creators of Spark that they have contributed to Apache Foundation. But since then, we had broadened our mission quite a lot. And right now, our mission is to offer our customers a first unified data analytics platform for 3 core personas. Those personas are data engineers, data scientists, and data analysts. So if you're one of those people, you're very likely to see tremendous value in the platform. And now we have some other products as well that I will touch on a little bit later. Now, since we broadened our mission, we acquired quite a lot of customers, in fact, over 5,000 of them. And here are some household names that are using us at a huge scale in production. Companies like Comcast, Shell, and HSBC doing some truly amazing things enabled by Databricks and truly accelerate their value they're getting from their data. Now, when we talk about energy and utilities more specifically, almost all of the use cases we're seeing when it comes to data and energy come into one of those 5 buckets. And some of them are really specific to energy and utilities, such as smart grid optimizations. Some of them are a bit less specific and can be applied to few industries, like real-time anomaly detection or predictive maintenance. And some of them are really broad and can be generalized to almost every single industry, such as churn prediction or trying to figure out customer lifetime value. So all of those things on the slide we can see running in production on Databricks. Now, the companies I showed you and that I mentioned are tremendously successful with their data journey. But what we're seeing in the industry is sometimes companies struggle to get from zero to AI in production in a very short amount of time. And we did a lot of research and thinking about it. And we realized that this is likely because the architecture is very complex. And as a data scientist, I can relate to this quite a lot. I want to use almost every single tool available to me in existence, but at the same time, I want business to get value out of the insights I provide. So it creates a mess, and if there are no processes or governance around the whole ecosystem, it becomes really, really hard to innovate, and it slows down your ability to deploy things. When we distill it a bit further, especially around companies that have a bit more legacy infrastructure and legacy code, not necessarily digital natives, but enterprises such as energy companies. All of the data problems typically stem from one of those four reasons. And this is research driven. This is us taking a look at what makes our customers successful and what was their state before we got involved and helped them out on the journey. The first reason is around data being messy, siloed, and slow. And I kind of touched on it already. But what we're typically seeing is people have deployed data lakes that turned into data swamps and became completely unusable. Then there are some warehouses, some on cloud, some on prem. There is some streaming data, batch data, structured and unstructured. And it becomes hard to put it in a way and a format that is consumable by business. And the second reason is that, well, even if you get this data in a way that is consumable by your team of data scientists, it's pretty challenging to productionize their work. And there are a few reasons of them, but I think Google did a really good job verbalizing it in the research when they have realized that something like 95% of the code in a typical machine learning project is actually not a machine learning code. It's all of the auxiliary infrastructure around it. Well, luckily, there are tools available to kind of take this work away from you because a lot of it is reproducible and a lot of it is a boilerplate. And this is where kind of MLflow kicks in, and I'll show you how it works a bit later. Third reason is more BI driven. What we're typically seeing some people, organizations do is they attempt to put all of their data into the warehouse. And while it works, it limits your scale. And if you do your BI on a fraction of your data, you will get a fraction of value out of it. And if you attempt to put all of your data into your warehouse, one of two things will happen. Either your data warehouse will become prohibitively expensive, or it will just not perform to the point that it becomes unusable. So we need a better solution here as well. And then even if you manage to stitch all of those open source tools together to get some best-in-class architecture and modernize your infrastructure, it's really hard to make it enterprise ready because its security posture is fragmented, and generally managing your own infrastructure and your own tools is a nightmare for your security teams. So here are the four reasons, and here's the solution that we're seeing. So I mentioned already that Databricks packages and sells unified data analytics platform. And at the bottom of it is our cloud service. So we would leverage, we're actually a cloud native company. We do not have an offering on-prem, but, and behind the scenes, we would leverage a lot of AWS. And we would engage with our AWS friends quite a lot to make sure that we follow all the best practices on cloud and make sure we use tools that they have and leverage them quite well. So we use cloud for storage, for compute, and provide you experience that is truly driverless. Now, on top of this, there is what we call Spark and Delta Lake for compute and storage respectively, to, well, first of all, decouple those two things so you can scale in a cost-effective manner and scale those things independently, but then also to provide reliability and performance. so that you could have things like asset guarantees, but on your flat file sitting on your S3 and things like that. And on top of that is really what drives the productivity. We call it a data science workspace, but in reality, it's just a data workspace for your teams to, sorry, I'll just close this one, for your teams to log in and collaborate across teams and within teams, getting from, I guess, zero to machine learning and data in production very quickly. And then there are BI integrations such as Tableau, Qlik, Looker, and some of our other partners if you want to be able to do business intelligence at scale. Now, this is all wonderful, but at the same time, as a company, we understand that while we should be an important piece of your infrastructure, we're probably not the only part of it. And this is where we leverage some of our friends from Intellify and AWS to make sure they have a complete picture. For example, if you want to offer your machine learning models as REST APIs, it might make sense for you to use SageMaker and use it in collaboration with the MLflow, where data scientists will do their work on Databricks and then deploy those models in SageMaker. Or maybe your data comes as a stream, and that's where you want to leverage things like Kinesis to push it out into Databricks to process and generate business value out of it. So this is a very short version of a pitch that we have and a very short introduction to Databricks. I don't want to spend more time talking about the company. I'll just jump straight into the demo. And when it comes to demo, I'll do a context setting first. So I was talking about three core personas: data scientists, data analysts, and data engineers. So during this demo, I will be kind of putting on my data analyst hat first, and then generating some insights, then my data scientist hat, and then generating a model, and then my data engineer hat and deploying this model in production. So we will walk you through the whole end-to-end lifecycle. And when it comes to the actual use case, we try to pick something that is relevant to your industry. So we found an open source data set around energy forecasting, and we will be driving end-to-end process from getting this data in to the point where we have this forecasting model scheduled and run in production, where insights are available to the rest of the business. So there are a few notebooks. I won't go through all of it. I'll just start with my data analytics persona. So I'm putting my data analytics hat and I will run some code. As a data analyst, I really like SQL. This is where I spend most of my time. So I would run some SQL queries to explore this data, because I've been tasked to figure out whether we can get a forecast out of it. Just a yes or no kind of question. Is this data forecastable at all? So it sits on Delta Lake, and keep in mind, this is a flat file that sits in your S3. So there's no data warehouse or a database behind it. It's completely serverless, if you may. So I'll run some SQL queries and visualize this data set. And I have many options to do that. It's kind of inbuilt in the platform. But here I can see that there is some seasonality between years. And this is just historical data around energy demand. So there is some seasonality. I'm hopeful. Now let me add some more data in, and I will run some joins and create some temporary views. So as you can see, this SQL is something your data analyst teams would already be familiar with. There is nothing new or nothing really that they don't know already, except now it is scalable and very, very cost effective. So I've decided to join this data set with my temperature data, because I have access to temperature data, and my holiday flag to see if it affects, to see if temperature affect energy demand. And then I decided to visualize it to see if there is some sort of relationship. And I can see that, yes, there is a relationship. If temperature is too low or too high, energy consumption goes up. And if temperature is between, let's say, 17 to 22 degrees, it kind of plateaus to the down here, which makes me hopeful that we can create a decent forecast out of it. But now I want to visualize whether there's been a change in consumption patterns over multiple years. And this visualization is pretty hard to do in SQL. So in the same notebook, I will use Python. And I will get this data out of Spark into Pandas. And now I can write some Python code instead of SQL to be able to run this visualization. So I'll write some Python code. As a data analyst, switch between SQL to things like R or Python on Databricks is fairly seamless. You can kind of mix and match languages as you see fit. And then I can run the same visualizations. And if inbuilt visualizations is not enough, you could always create your own and use your own tools, or maybe plug it into some BI tools that you have. So I'll just add a year over here. And I will check whether the consumption pattern is the same. So I can see it is roughly the same. There hasn't been any dramatic change, which is good because it made this predictable. But what about the data distribution? So I could see that the distribution hasn't changed either. So I'm happy with my job. I will now create a dashboard. And I will make this dashboard available to the data science team. I will basically create a link and share it with the data scientist to further productionize it. So now I'm taking off my data analyst hat and putting on my data scientist hat. And now I want to forecast. Before I do that, I will just explain to you a little bit how people typically interact with Databricks when they do machine learning. So what you see in front of you is a very typical end-to-end process from raw data up to the point where you score your new data and make it available to the rest of the business. And here is how Databricks can facilitate it. So raw data is stored on your Delta Lake, which you can run your SQL on and do some analytics, do some data engineering. And then you have environment set up, which is taken care of by Databricks because we're using something we call machine learning runtime that would contain a set of prepackaged tools and libraries that your data scientists typically like to use. And if something is not available, you can always install your own, which makes your environment reproducible. And further down the line here, between feature engineering to model scoring, the process is fairly standard across different projects. You engineer features, you do exploration, all of those things to the point where you arrive at the best model. Now, in a typical day, data scientists would create multiple new models and run multiple experiments. And over time, it can cascade into quite a messy state where you would have hundreds of models to pick from, but you don't have a good documentation or a way to understand which is the best one. So people use things like Excel spreadsheets, sticky notes, etc., which is not a scalable solution. So in Databricks world, we have something we call ML flow tracking for you to be able to use and track your work. And then for handing over work between data scientist and data engineer to make productionization a little bit easier, there is something that we call ML flow deployment and ML flow registry. So, so the data engineers can frictionlessly pick up work of a data scientist and productionize it. But I guess enough about that. I will now create a forecast given the insights that our data analyst team has generated. So as a data scientist, I like Python and I would write a lot of Python code. So I will split my train and test data as usual. And I looked at the dashboard and I realized that Profit is perhaps a good framework for me to use. And Profit is a quite popular library that's open source. It's been open sourced by Facebook that is very frequently used for forecasting because it can take into account seasonality, holiday effects, and temperature and things like that. Before I do that, I will just go ahead and create a machine learning experiment. And this is for me to track my work. So everything I do in this notebook, sorry, I think it exists already. Everything I do in this notebook will go there. I'll just name it 1. And I will grab this ID and I will plug it in here. So now everything I do in this notebook will basically be pushed into this experiment. And now I spent a few hours and I came up with a few models. Now I just want to run them and see how they perform. So this one is fairly basic. It will just take the data that we have and plug it into Profit and generate a forecast. And we can see it kind of matches here. So it's not amazing, but it's not horrible either. The problem here is that it cannot predict those peaks and somewhat look like anomalies. So I'll try a slightly different model and see if it makes it better. And I can see that it's not significantly better. So perhaps I want to add new features and experiment a little bit further. So I did some thinking and I have decided to add such features as daily average temperature forecast and a holiday flag and a square of a temperature as my new features. So I will add them and I will tell Profit to use those as well and see if it improves my forecast. And I can see that now it is much better. It improved my forecast quite a lot, and it can actually detect those peaks. Maybe they're temperature related, or maybe they're holiday related. We don't know yet. And I'll try another model as well to see if it's a little bit better. It's not significantly better, so I can continue experimenting. But for now, let me just go back to MLflow UI and refresh it. And I will move this thing somewhere here. And now I can see that all of the runs that I did are here, so I can keep track of my work. Let me filter out those by performance. So MAPI is a performance metric that I want to use, and the lower it is, the better. So I'll just select those two to compare. And now I can compare them. And I can see that they're mostly very similar models, except that one used seasonality mode of multiplicative, another one is additive. And those can be 100 models or thousands, and we can compare those programmatically or through UI now. The point is now we can figure out which one is the one that we want to use, even if it's not the latest model. I'll click on this one and check it out in a little bit more detail. So I can see that, okay, it looks good to me. So I will just go back to my modeling notebook and I will register it. I will tell MLflow, hey, MLflow, can you please create a model called Energy Forecast Profit? Can you search for the best run in this experiment? And can you push it out to this model name so that it would be available to other people? And then I will go here. And I can see that, okay, now I have a version 1 of this energy forecast profit model. So I'll click on it and I can add some description here. Forecasts energy, uses temperature, temp squared, and is holiday flag. And I'll save it. And now I'm taking off my data scientist hat and putting my data science. Actually, and before that, I will request it to be transitioned to production. And now I will sorry, transition to none. I did the wrong thing. Request transition. I will request it to be transitioned to production. And then I will put my data science hat on. So as a data science lead, I got a ping from my data scientist to basically take a look at this model and see if it's good enough to be productionized. So I can see there's a request from someone to be approved, and I can take a look at it. I can go to source run, and I can see everything I need to know here. So I could go here in visualizations and see the actual forecast that we've decided to push into MLflow. And I can see that it's pretty good. And also this performance metric is reasonable. And I can see components here. Okay, it seems like energy consumption overall is going down according to this model, which is consistent to what I think. And then I can do code review. I can actually click here and see the exact code that resulted in this model. So I did code review and I'm pretty happy with this model. I will just go back and approve it. So now this model has a tag called production and other people can use it. And there can be many different tags. So now I'm kind of taking off my data science lead hat and putting on my data engineer hat. As a data engineer, I just got a ping from data scientists and I'm tasked with productionizing this energy forecast model. And I have this link. So I can go back here and I will click on the source run again. And I can see all of the things that I need to know, except now I'm more interested in this folder. And I can see that there is a model file that can be serialized and loaded by MLflow. I can see there are all dependencies here. And there is enough for MLflow to know to be able to load this model without me actually having to care what's inside of it. So I'm happy with this. And I think I can productionize it fairly easily. So I'll create a new notebook and I'll call it deployment. And then I will just create a MLflow client. And I will ask MLflow for a model called Energy Forecast Profit. And I will ask for the latest production version of it. And now I have this model. Except now I will go back to documentation and realize that it's using things like average temperature, which I don't have. So what do I do? Well, the first instinct is to, well, panic and ask for this data. But then I realized some other people have been working on weather forecasting in my company. So I will just search in my model registry. And I can see there is some model that is available already. So perhaps I don't need to do some extra work. And I can see there are 4 versions. First of them failed. And then 4th of them is actually in production, so I can use it. And someone was kind enough to write documentation that I can read, and I can go through the code and through runs to figure out how it works. But this looks exactly like what I need. So I will grab this model. I will remember name, weather forecasting API, and I will load it as well. And this is a very important point. So this is how you can create this multiplicative effect within your organization. Once you start pushing more models in production ready state, a lot of people from different parts of organization will start using them for their projects. So it will create this natural synergy between different teams. So I will load it. And now I can basically get a weather forecast, which by the way is a live weather forecast for Victoria, for Melbourne. And now I can massage this data and plug it into historical data to generate the actual energy forecast. And I can see that it roughly matches my historical data. So I'm happy. And let's pretend I would write some code for it to be pushed into Delta or some database, data warehouse, and made it available to my BI teams. Except now I will productionize it and I'll schedule this job. I'll just click here, create a new job, and I will tell it to run once every day at certain time, and I'll click OK. And this will lead me to job UI where I can monitor my job execution and see if it succeeded or not. So this was the demo. I think it concludes it. Now we can go back to a Q&A session. So in the interest of time, just paste your questions either around my part or Kale's part of the presentations. And let's ask as many as we can. But if we can't finish them, we will collect all the questions and answer them in the email. Thank you.
Fantastic. Thanks, Jan. So I'm just looking at the poll at the moment. Have people been submitting questions so that everyone could see it, or have they been sending private messages? Because at the moment it only looks like that there's one message in the chat. So feel free to submit any other questions that you have, guys, because at the moment, from my side, I don't think there's any.